I'm Bones Orbital, and this is a in-depth tutorial on mortars for Arma Reforger. Enjoy! Now, if you look here, you're going to need a calculator, and you're going to need some sort of way to take notes, which will be like so. So, right here, at the top of this little note screen here, I've got the mortar pitch equation. Now, some of these terms, I will say, are handmade. I worked this equation based on, I guess you could say, like the best way I knew how to explain it and kind of simplify it into one compact thing. Now, one thing to note here is you do need the mortar ballistic sheet, because that's the only way you're going to be able to get your correct ranging for your mills here possible. And draw your lines straight through your fobs, or wherever you're trying to get mortar fire to look at the kind of the inner line here, right? So it's a 360 radial, alright? Now let's say we're gonna dial in on Louisiana Outpost Thunder. Alright, if you see here, the line on this inner radial measurement here is right at 95. Our range, in order to get that, you're going to take your protractor and rotate it. Alright, now, kind of the same situation as far as getting it centered and lined up. You see how you have your double hash marks here for your 0. Alright, you kind of want to position yourself in the middle of it and then work your way into getting this as flat or parallel with your pencil marking as you can. Alright, now the way that these work is, this is meters, right? So 0, 100, 200, 300, so on and so forth. Alright, these are your half marks, so that would be 550 meters. 10 is going to be 1,000, so you see the Outpost Thunder is just outside of 1,000 meters. So what you would want to do here is you're going to take and mark here, kind of at your 1,000 meter mark, and draw it out just enough that you can see it. So when you go back and you grab your protractor, you can kind of move it down to see where you're going to be. So in this instance, Outpost Thunder is going to be approximately 1,100 meters. So then we're going to go back to our notes, and we're going to note that. So we're going to go 1, 1, 0, 0, put an M so we know that it's meters. 4 rings is simply going to determine your flight time, right? And if you look in the middle of the ballistic sheet, it says time of flight, right? So at 1,100 meters exact, we're looking at about 36 seconds worth of flight time. Your rings, you can adjust that. So let's say, alright, we're going to go here, we're going to grab a mortar shell, and if you inspect it, alright, it says change number of rings. You're going to hold that down, and you're going to get 3, 2, or 1. And depending on how many you have on the round, like I said, is going to determine how long your flight time is. Your elevation, in translation, is going to be your pitch, right? So let's go right here. Alright. Now, we need to have our pitch at 1405. So we're going to aim in. Alright. On the bottom of the screen, you'll see your radial mills. Your radial mills is, once again, that's going to be your directional fire. So remember, we were at 95 on our mills. we're going to adjust to right under the point that it changes your milling. Now, on the left side of the screen, you see where it says 0800 for your mills. That is your pitch. That is the elevation of the tube in order to achieve the correct angle to get fire effect on your target. So we're going to go up to the 1405 that we made note of before. Down a little bit. Okay. Now, according to our ballistic manual, for high explosive shells set to 4 rings, which would be a 36-second flat time, we are in line to start firing these shells onto target. So let's take a point like Georgia. Okay. So we're gonna make this mark like we did last time for our 1,000 meters. Okay. And we're gonna drag our protractor down to where we are in line, like last time. Alright. That's kind of it. It should be close enough. Yeah. Alright. So right now it's showing Georgia is set. Remember, that's our 1,000 meter mark. So we're going 1, 2, 3, 4, 5, 6, 700 meters. 710, right? Because it's right on this first hash mark leading up to the halfway hash. Alright, work on our radials now. And that puts Georgia right at, let's say 99, right? 99. It's not quite 100. Take note of the left-hand side where it says 1,700. Okay. Now, here's where it gets tricky. If you notice your elevation, the shorter the range, the higher your mills are, right? So, when we go to the equation here, and you look at rem H, okay, that's your range in mills highest number, right? So if you look here, the example I have is 800 meters equals 1,460 mils. And then if you look at your rem low, alright, your example is 900 meters, it's further out, but your elevation in mils is a lower number, which is important. Because what you're going to do here is you're going to take your rim high and your rim low, and you're going to subtract the rim low from the high. So you're going to take the lowest number and subtract it from the highest number. So in our case, we've got 1283 minus 1261. So let's get that calculator up for quick math, right? So 1283 minus 1261. That's right. 1283 minus 1261. Okay, and that's going to be 22. Alright. So now we're going to go back to the equation. Now, right here you have your DIM. D-I-M. Alright, that's your difference in mils. Okay? And in our case, our difference in mils is 22. So we're going to take that, and we're going to make note of it. Because we're going to have to divide that difference in mils by 10, because it's broken up into your meters. Your ranging is broken up into by 10 meter I guess instances or segments per se. So you want to know the difference there, which is going to be like 2.2, right? So now you have your, what is considered, or what I labeled, the high-low difference. So now you've taken your DIM here, which was 22, and divided it by 10 to get your high-low difference. Alright, now now you're going to go and multiply your, or let me go up here and show you. So once you have your high-low difference, you're going to multiply it by the meters to point. Alright, so if you come right here, your meters to point, the example I have here is point is 860 meters. So from 800 meters, it is 60 meters to point, which will be represented as 6, right? So in this instance, because our objective, our point, is only 10 meters further from the 1700 mark, we're going to take that 2.2 and times it by 1. No difference, right? So, now you're going to figure out your pitch. Alright. So, backstepping a little bit here. What we did, alright, when we multiplied 2.2 times 1, alright, we were getting what is called the correctional mils. So that's how much we're going to have to change our elevation pointage in order to get it accurate. And I'll show you that here in just a second. Okay, so we know that because there was no difference, our correctional mils is 2.2. So now we're going to go back, our rim high, right, which was 1286 or 1283, like right here. So we're gonna do start fresh, 1283. All right, and we're going to subtract 2.2 from that, which is going to give us 1280.8. Now this new number here is going to be our pitch, our elevation. So when we go back here, alright, because we're done with the manual, remember the 1280 that we got from doing the equation here for our pitch? Pull the calculator back up, remember? Alright, that is going to be our elevation. So now we're going to move up until we reach 1280, like so. And because you don't really get a decimal, an extra decimal point there on the left side for your elevation, you either want to round up or round down. We'll throw this equation back up here, so that way you can pause it, take notes, copy it, however, and be able to kind of follow it along a little bit better. It is also important to remember that the difference in your mortar shells also determines your flight time and your range. So for example, if you're using smokes compared to high explosive, your smokes are going to have a different range effectiveness and a different flight time. The equation is universal. As long as you know what round you're using and the rings that you are adjusting to, you can still make use of the equation and get as accurate of a calculation for your